Hello and welcome to Generative Geek. My name is Vaibhav, and in today's exciting tutorial, we are diving deep into the world of Google's Gemini models. Whether you are a developer, a tech enthusiast, or just curious about the capabilities of AI, this video is packed with insights. We'll start by guiding you how to get your API keys, and then we are going to make use of those API keys to call the Google Gemini LLM. Then we'll explore the diverse family of Gemini models. And I'll show you how to interact with the latest Gemini Pro 1.5 and the newly released Flash 1.5 models from the recent Google I/O. Stay tuned as we also decode the power of Gemini's vision models and dive into the intricacies of building chatbots with multi turn conversations. Let's get started and unlock the full potential of Google Gemini together. So now let me quickly show you how can you get your own Google API key for Gemini. So we'll say Google Gemini API key, and we'll go to get an API key for developers, right? One thing that you need to note is that Gemini is probably not available in all the regions. So you should check if it's available in your region before you get started, or use a VPN when making a call. So get an API key. This will take us to makersuite.google.api key. And I'll just take that URL, open a different tab window, because I want to show you from the scratch. So it will ask you to do some consents and stuff like that. We'll say, I probably don't want on this email. Yeah. So we'll just say continue. You can have like you can you can have all of them checked and then press continue. Next, what we'll do is you can see that there is an option to get API key. So we'll say create API key. It will ask you to accept something, and it'll be all right. Next, we'll say if you already have a Google Cloud project, you can set this key under that project. I don't have one, so I'm just going to say create API key new project, and then it will it should generate the API key and show it to me here, right? So this is generally the process. And there you have it, right? So this is my key. I can just copy it, and once you have copied it, come back to your Colab, and you can paste your key here, right? So against the Google API key, you can, if you don't already have that secret, you can say Google underscore API underscore key, and you can then paste that key value here, right? So that's how you create keys, right? So um, I'll just go here, again, press this. I should see the key. Once that's done, your key should show up here. This is free of charge, but I don't want this key, so I'm just going to delete the key. Also, I expose the key to you, so I anyways need to delete this, right? So this is how you set up your. So let's first install the necessary dependency. We need Google Generative AI library. So I'm just going to say pip install Google Generative AI, and this is basically coming from this page. If you go to the Google Generative AI page on PyPy, you will see that the way to install it is pip install dash u. Dash u basically means update it in case if it's already installed and there is an available update. So now it's getting installed. It's already installed. So what we'll do is we'll say import google.generative AI as gen AI, right? And what then we'll do is we'll say import OS, and from google.colab import user data, right? So I'm doing this Google Colab import because I have my keys, the Google Gemini key in and all other keys in the Google Colab secrets manager. So I'm just going to give this thing an access. My key is called Google underscore API underscore key. I'm not going to show you obviously the variable value, but this is how you can set up the key and then call user data to fetch the key, right? So once the key is fetched, I can do os.environ, and I'll say Google underscore API underscore key is equal to user data Google, same thing basically. Yeah, Google API key, This what this will do is it will read the key from my secrets manager and assign it to as an environment variable, right? I'm going to run this, then I'll say Gen AI, okay, module object is not subscriptable. Okay, yeah. So this is probably user data dot get, and let's just see, right? So should work this time, hopefully. Yeah. Next, I'll say genai.configure. This will configure the key for me. And how do we know that our GenAI, Google Gemini generative AI thing is configured? What we'll do is we'll list out the various models, right? So list various models. And for that, what you do is I'll import pprint first, and then we'll say for model in gen AI dot list underscore models, we are going to loop through each model and we are going to print model, right? So let's just first print all the models that this thing has, right? And then I'll tell you how generally you want to which are the models that you usually want to pick up, right? So it's printing out all the models. It's saying, hey, these are the various models. There's model called model slash chat bison, and here you see that, what are the supported generation methods. You see that there is a generate message available. I'm trying to maximize. Something is not right. Okay. So I'm not able to maximize. Yeah, now. So yeah, so there is a chat bison, which is basically generate message and count message tokens. Now next you have text bison one, you have generate text. The models you want, basically you want to pick up, are the ones which have generate content in them, right? So you have Gemini 1.0 Pro, you have Gemini 1.0 Pro 001, Pro latest, Pro Vision latest, Flash latest. This is the latest model that Google released at their Google I/O recently. And you can see it has generate content, right? So what I can also do is I can say, hey, for model in Gen AI list, if model dot supported, if or we I can say if generate content in model dot supported generation methods, then only I want to print the model name, right? So instead of printing all the models, I just want to print the models which have generate content in their supported generation methods, right? So now you see only those models will come. You won't see the chat bison and all the embedding models, right? So yeah, so for this, what we'll do is we'll make use of Gemini 1.5 Pro latest, and we'll also make use of the latest Gemini 1.5 Flash latest, right? So if you go to Google Gemini Flash, um, we can see that, Gemini Flash as a model has longer context, built with 1.5 Flash. Let's just see where it takes us. No, not this page. I had a different page in mind, but yeah, maybe I'll show that to you towards the end of this video. Next, what we want to do is we'll pick the model from here. So I'm going to pick Gemini Pro, Gemini 1.5 Pro latest. So this becomes my model name. This will be the model that I'll be working with for now. And you set the model as Gen AI. Model is equal to Gen AI dot generative model, and you give it the model name, right? So when we do this, we are basically saying, hey, this is the model, this is the LLM we want to interact with. Next, you want to quickly check whether this thing is working fine or not. We'll say model dot generate underscore content. If you remember, this is what was supported, right? So we are going to say prompt is basically nothing but what is the meaning of life, like, let's just say, right, what is the meaning of life. And I'll say print response dot text. And what this will do is it will make a call to Gemini 1.5 Pro latest with this question, and it's going to print the text, right? So as a large language model, I'm not capable of providing an answer and all of that, right? So now let me just use the Gemini 1.5 Flash latest and see what turns up, right? So I'll say model underscore name is equal to Flash latest, and then the same thing. So we'll say model is equal to generative AI model name. Response is again same, and we'll say print response dot text. Um, it's making a call, to the Gemini 1.5 Flash. And if you see, why in case of 1.5 Pro latest, it kind of said, "Hey, I might not have an answer for you, right? Ultimately, meaning of life is a personal question, and all of that." Flash latest, and these things are like, if I make another call to the same model, I might get a very different answer this time, right? So let me just try that as well. You can't expect the same answer to show up both the times, right? So this is a very probabilistic output generation method. Um, this this got into philosophical aspects, religious perspective, and rather than searching for a say, it may be more useful. So this basically, my objective here was not to find meaning of life, but my objective here was to just help you, demonstrate to you how you can call various method models and then send a prompt and get a response back, right? So this was how you call various text generation models. Like, both of these models are multimodal, by the way, but this is how you call them. The next thing I want to talk about or demonstrate today is how do you work with vision, right? Working with images and vision, right? So what we'll do is I'll go to Unsplash. Unsplash is a popular website where you can get a lot of images, and I'll just say food image, right? So I'll just take some food image. Maybe I'll take this burger, looks nice, so I'll just take this burger. And then what we'll do is I'll upload this here in my files, right? So I can say whatever this image is, and it gives you a warning saying, "Hey, you know what, this is a very ephemeral instance, because we are saving it here on the instance." Rather correct way is that you mount the Google Drive, and earlier you had to write code to mount the drive. Now it's available on the GUI, so I can just click this and it'll mount, and I just need to basically give some permission, not mounting it right now, but yeah. But you get it, right? So I'll just rename this. I'll say food.jpg. And then what we'll do is okay, it wrote some code for us. What we'll do is I'll basically first, no thanks. Okay. If we want to work with images, the library we'll need is Pillow. So I'm first going to install Pillow. And once we have Pillow installed, we'll just say our img is equal to, okay, let me close this. Image is equal to pil dot, okay, we haven't imported pil, so we'll say import pil, and then we'll say img is equal to pil dot image dot open, and my file was called food.jpg. Let's see if it can read the file. Okay, it seems it has been able to read the file. Now we'll say for images specifically, what I want to do is I want to go back to our model list and say, hey, 1.0 Pro Vision latest seems like the latest model. And we'll send Gemini Pro Vision is also there, right? Okay, let's just send it to the 1.5 Pro. So I'll say model name is equal to Gemini Vision latest. And what we'll do is, just like we did earlier, our model is generative model name. This is how you instantiate the LLM. And next we'll say response is equal to model.generate image, not generate image. The model is on generate content, and we're going to pass it the image, right? So what we are doing is, this is a vision model. So we are saying, hey, you know what, take this image and tell me what it is. And we are going to print the response.text. Let's see what comes back. Um and then I want to quickly also send the same thing to a different model and see what comes back, right? So I want to send the same thing to the Flash model, right? Because it's also a multimodal model. So let me see if it can. So it's saying two delicious looking burgers on a wooden table. The burgers are made with sesame seed bun, lettuce, tomato, onion, and cheese. They are served with a side of Coca-Cola. In case if you forgot about the image, this is the image we had, right? So it can even read that there is a Coca-Cola there. There's lettuce, there's some burger patty, and it gave a pretty onion, tomato, onion I can see. I don't know where it saw tomato, but yeah. So assume that it will try to do. Does it have cheese? Maybe it can infer that there is some cheese, but I don't see any direct cheese here. Let's just try a different model now, right? And see if it works or not. So we had the flash model earlier. Let me just try and make a call to the flash model now again and see if it works. I don't know if it'll work or not. I'm trying it for the first time myself, right? So let's see. It's doing something. And let's see what the flash model comes back with, right? This is a delicious looking photo of two burgers on a wooden plate. The burgers are made with a sprinkle of salt. Okay, is there? Yeah, so seems like there's some sprinkle of salt. Okay. Yeah, the burgers are stacked with juicy beef patties, avocado, radish, and spinach. Okay, very different. Beef patty, correct. Avocado, spinach seems like a better interpretation, better inference. The background includes a wicker basket and two bottles of Coca-Cola. The photo captures the perfect moment of anticipation for a tasty burger experience. I personally found the output of Gemini 1.5 Flash latest to be better than, in terms of describing the image, better than actually the vision model, right? So this is how you basically try out different models. So now I want to show one interesting concept called streaming. What we have been seeing so far is that when we make a call to generative AI, the response comes back in one go, and we then print that response, right, once it's done. There's a very interesting thing, and let me just show you. I've written some code. I've pre-made this. And it's very similar to what we were doing on Google Colab. Now this is Visual Studio Code, so I have import OS, same imports. It's just that my secrets are now in a .env file. So instead of Google Colab, I'm now reading them from the .env, right? And then we are configuring Gen AI the same way. We did not have to configure it there. We actually don't need to configure here as well. I don't need to give the API key. It should still work. But yeah, it's there, right? And I'm going to use Gemini 1.5 Flash latest. That's the model, and we'll instantiate the LLM model. Next, we are saying responses model or generate content, standard stuff that we were doing on Google Colab. Tell me a story about a magic backpack in 1,000 words at least. Now let me run this, right? So oops, I did not need a split. So let me just run this. I'm going to say Python Google streaming. And you see, it's now waiting, right? Because it's waiting for the entire story to get completed at the model's end. And once it's complete, it will then be outputted back to us. And so it's going to take a little while. Okay, I think I forgot to print. Yeah, so there was no print response.txt. Let me just print this and again run it. Uh, we'll do Python Google streaming. So let's see. So now again the same thing. Sorry, you have to wait again for this. But what is happening is it's gone back to the model and it's generating the story that we have asked it to generate. And whenever the generation is over, it will spit out the entire thing in one go, right? So this is some story it made up, right? The air hung heavy with the scent of rain and all of that, right? So this is like 1,000 word story that we asked Chat GPT to Google Gemini to create, right? Instead of this, now let's just say I don't want to wait forever, right? So what we can do is we can just type stream is equal to true. And with this, once your prompt is done, just say stream is equal to true. And we'll say for chunk in response, print chunk dot text, right? So what's going to happen is it's while it's generating, it's going to keep outputting these chunks, right? So it is not going to wait. That's the whole concept of streaming. Don't wait for the entire thing to finish. uh, Send it downstream as whatever chunks you have, that you whenever the chunks are ready, right? So let's just run this again. I'm going to just give some space and say Python, maybe clear this window, right? So I'll say Python Google streaming. And now you will see that, as it generates, so you can see how the text starts coming, right? So it's coming while the model is generating, whatever output keeps happening, it will keeps getting built, it will keep sending the output downstream. And you can see how this entire model is now working with streaming is equal to true. It's again going to build some story, maybe not the same story, but some story. And that story is, instead of packing the entire story in one go, it's sending these chunks, and we are printing the chunks, right? We are printing these chunks because we have this loop going on, right? So as the chunks come in, whatever chunks are there in the response, we are just printing those chunks, right? So that's what is happening. I think it should be getting done now. Doesn't take that long, but you get the gist, right? So this is how this thing works. So this was about streaming. One thing that you need to remember is that these models are stateless, so there is no memory as such. I have already done a video where I have talked about how do you add memory to the chatbots. And if you go to my videos, you can see that there is a video on how to add memory to your chatbot. If you watch this video, you will understand that I've talked about three different ways of adding memory to the chatbot using LangChain in this. Uh, but here, let's just say if you want to build a multi-turn chat system, how will you do it, right? So what we'll do is we'll say the key thing here is that you have to pass the history, right? So, and I'm going to basically demonstrate a very simple system here. So our role, you will say the role is user, and parts, yeah, just basically first going to instantiate with hello, right? So this is my messages, and I'll say response is equal to model dot generate, same thing, model dot generate content, and we're going to pass it the messages, right? So let's see what comes back, right? So print response dot text. I just want to show you what it sends back. So it says, "Hello, how can I help you today?" So we sent a hello, and it's responding back with a "Hello, how can I help you today?" Now what we'll do is we'll say messages dot append whatever it has sent. We'll say response dot candidates zero dot content. So I'm now adding whatever the AI has responded back to the array, right? Back to the list, saying, hey, whatever you have sent back, I have added that to the messages. Next, what we'll do is we'll say messages dot append. Now assume that these messages dot append, especially where the role is user, that is coming, if it was like a chatbot kind of a system, this was coming from the user directly from some sort of a text box. But in our case, we are just typing things here, right? So I'm saying role is user. What is the part that we are sending? How does quantum mechanics work, right? So I'm just going to send this question, right? And let's see what comes back. So this becomes the message. We are just going to say response, same way. Response is equal to model dot generate underscore content, and we are going to pass the messages, right? So we'll run this thing again. Just for your understanding, again, we started with this message. This would have come in from some chat window to us where the user is saying hello. The response will come in. Whatever the response is, we are now appending the response back as back to the messages list. Then we are appending whatever the user has sent, right? So the user will send something again from the chat window, and this time the user is sending how does quantum mechanics work. We are now passing the entire messages as to the model, using generate content, and that becomes my response. And now we are again going to print response.text. So let's see what comes back, right? So it says quantum mechanics is a mind-bending realm and all of that, right? So this is how you can see. If you just want to see how messages looks like, you can type messages. It will show you how messages looks like. Yeah, so it says it's a list. First is role user parts hello, then parts came which is text hello, and role was model. And so this is what the model replied back. This is probably some emoji that came, so it's the equivalent of an emoji. Next, the model said how does quantum mechanics work, and whatever has come back, we could have again said the same thing, where we can say, hey, messages dot append response candidate, right? So, and next we can again send something where what the ex I didn't get it, right? So let's just say I ask it what I didn't get it. uh, and so let's just do that, and then print response.text again. So what we are saying is whatever the model responded back, we are just saying, hey, I didn't get it, right? So the model is probably going to make it easier for me to understand this time. It's still going on. It's on the last cell right now. Once that runs, then we'll see our response. You're right, quantum mechanics is tough to grasp. The video game analogies are meant to, so you see, I just said I didn't get it, but it was able to infer, see the history, because we are passing it the entire message, right? So this is how you do multi-turn conversations with Google Gemini. The goal of this video was to just help you get started. In the next video, I'll try to make a GUI based chatbot, which you can run on your systems using an OS based, not a web based. So yeah, so stay tuned for the next video. Thank you. Thank you for joining me in this deep dive into the Google Gemini models. I hope this session illuminated the powerful capabilities of these AI tools and inspired you to experiment with them in your own projects. Don't forget to like, subscribe, and hit the bell icon on Generative Geek for more tech tutorials and cutting edge AI insights. Have questions or want to share your experience with Gemini models? Please drop a comment below. I love hearing from you. Until next time, stay curious and keep coding. Thank you so much.